squareds, right? So it says if you got even powers, then use the half angle identities. Well, I'm going to use the cosine squared identity on this one. This is equal to integral 1/2 1 plus cosine 2x dx. That look okay to you? The 1/2 could have come out, couldn't have? I could have pulled that out in the very beginning. But I just want to make sure everyone understood where it was coming from. And then now, just looking at this, I'll put the 2x right there. I won't put it in parentheses, just hoping that everyone understands that's the argument right there. Can you integrate that? Yes, term by term, right? Separately. So I'm going to have 1/2 and then two things. So antiderivative of 1, x. Antiderivative, careful, antiderivative of cosine of 2x. 1/2 sine of 2x. Right? Then we could. Yes, I just plus c, that's all I remember, plus c. Which would become, yes, if we distribute 1/2 x plus 1/4 sine 2x plus c. That'd be it. That pretty straightforward? That doesn't look so bad, does it? It's about to get bad. But that seems okay, right? All right, so let's take a look now at part C. So the only difference in part, the one I just did in part C up there is it's a fourth power, right? Instead of x, I'm using beta t dt. Can you, how do you mean? Yeah, you can make this 2 cosine squareds.
And then just within those.
Yeah. Yeah, watch. That's exactly what we're going to do. It's going to be, but instead of doing 2 separate, is it all right if I do this? Like this. Squared. Is that all right if I just write it that way? I mean, we're going to get to the same place. Is that okay? What does this inside piece right here turn into, though? So I'm using the formula, right? It's going to be, and remember, it's all of that squared, right? It's going to be 1/2 times 1 plus cosine, cosine what? 2 beta t. Aren't you supposed to double the angle? And if the angle is beta t, you have to double it, so 2 beta t. So 2 beta t, all of that squared dt. All right, let's make sure we understand this. Cosine squared of beta t is equal to 1/2 times, in parentheses, 1 plus cosine of 2 beta t, close it off, all of that squared. You are not allowed now to go in here and integrate these piece by piece, right? Because it's being squared.
And you can't take the 1/2 out because it's inside the...
Can't take the 1/2 out because it's being squared also. Now you could, because you could square it and then get it out of there, which I will do on the next step. But I just want everyone to understand and appreciate that it's not as easy as the last problem was. Yeah? So here's what I'll do. So what happened there? Just split it up. Because this is multiplication right here, right? If you have 2 things being multiplied that's being squared, you can square each one of the factors. So that's what I've done. And this 1/2 will come out as a 1/4, won't it? Okay. Let's pull that out. I've got 1/4 integral, and then 1 plus cosine of 2 beta t squared dt. Any ideas? What do you mean?
Same thing.
Expand those out, expand it out. That means square it. You know, square it out. So you have to do this. I'll go slow since it's our first example. You have to go and do 1 plus cosine 2 beta t, right? 2 beta t times 1 plus cosine 2 beta t again. That's what it means to square it, dt. And then you go through and FOIL, right, Ramiro? FOIL. That's funny, Ramiro. I'm going to remember that for a while. You know, speaking of something, y'all don't know what we're talking about. It's an inside joke because he came by my office. Things aren't always the way they appear. I remember growing up, seeing this sign on the side of the road. Like, here's the sign, here's the pole. And it was this sign. I don't know if you've ever seen this before. No, this one right here. Have you ever seen that? It's like the neighborhood watch, right? Have you? Yeah. That's what I thought it was sailboat on a hill. And it's a crook, you know, with his cape and his hat, and that's what it is supposed to be. And it's got like the, you know, no criminals through here. And I remember being like, you know, in grade school and asking my dad, like, why are they saying there can't be ships on a hill in here? And it's like, my dad knew right there. He was in trouble. No, but I'm just saying that, you know, things aren't always the way. You think they're a certain way, and it's like totally not that way. Okay. All right. Do you see what's gonna become a problem as soon as we do this?
Beta.
When we do the last part of this multiplication, we're going to get a what? A cosine squared of 2 beta t. Again, we're going to have cosine squared in here. Let's do it, though. 1/4 integral. We have 1, right? That's our first multiplication. Then when we do the inner ones, we'll get 2 of the cosine 2 beta t's. And then we get plus cosine squared of 2 beta t. So there are the 3 terms we would get if we were to expand that out and collect like terms, yeah? Can you integrate this? Yes. Can you integrate this?
Yeah.
Yeah. Can you integrate this? Not yet. What am I going to have to do to integrate this? Use the power reducing formula again to bring that power down. Just like the previous example, right? You see that?
Right.
So I'm going to take care of these two right now. I'm going to take their antiderivatives. And on this one, I'm going to kind of say I'm not able to do it yet. So watch. I have the 1/4 out front. What is the antiderivative of 1? T, right? Because we're integrating with respect to t, so t. All right, now, what is the antiderivative? Careful here. Antiderivative of 2 cosine of 2 beta t. So cover up the 2. What's the antiderivative of cosine 2 beta t?
1/2 sine.
Almost. 1 over 2 beta sine of 2 beta t. Do y'all agree with that?
Yes.
Because the scalar in front of t is 2 beta. So you have to scale by 1 over it. So 1 over 2 beta sine of 2 beta t. 1 over 2 beta times sine 2 beta t. That's what you said? But what's in front of that? A 2. That 2 here cancels. So it's really just 1 over beta sine 2 beta t. Right? Times 1/4. So 1/4 or 1 over 4 beta sine 2 beta t. Jeez. Now, you could have passed the 1/4 through and done it all, you know, however, but we should all get to that. Now, should we check it real quick? The derivative of this is cosine of 2 beta t times 2 beta. And if you multiply that times 2 beta, you'll get 1/2. And so if you multiply 1/4 times 2, you get 1/2. So it does work. So we taking care of the first two?
Yep.
But we still have this one, and we still have a 1/4 out front. So I'm going to put plus 1/4 integral cosine squared of 2 beta t dt. So what should I do on this?
Multiply them again?
This is, we're starting this over. Basically, we're looking at this going, you have a trig function to an even power? Yes? Half angle identity? So I'm going to do the half angle identity on this right here. So this becomes 1/4 t plus 1/4 beta sine 2 beta t plus 1/4 times 1/2 integral 1 plus, you tell me. So this right here, when we use the formula, we get a 1/2, right? The formula has a 1/2 in it. That 1/2 will always be able to come out of the integral. So that came out right here. Do y'all see that? Then it's 1 plus cosine 4 beta t. Because you've got to double the angle again. You see that? The formula says that the power can come down as long as you're willing to double the angle. And if the angle is 2 beta t, it's going to become 4 beta t. So this becomes cosine 4 beta t and then dt. And there's no, we didn't do any integration here, right? This was just a formula to go from here to here. Now can we integrate it? Yes, antiderivative 1, t, antiderivative of this, well,
Beta
1/4 beta
sine.
sine of 4 beta t. Then we'll have to hit it with 1/8. But we'll get to that. So we have 1/4 t, 1/4 t, sorry, plus 1/4 beta sine 2 beta t plus 1/8 parenthesis, because this 1/8 distributes. Now I'm going to do these antiderivatives. It was just t plus 1/4 beta sine 4 beta t plus c. Do y'all have questions on that part?
Can you just say that again?
That.
The integral part. Can you say that again, like to the answer?
Like,
So you went to t here and then.
okay, antiderivative 1 is t, right?
Yeah.
Okay, and then antiderivative of cosine of something is sine.
Uh-huh.
But then you have to scale by what's in front of the variable. So 1/4 beta,
Yeah. So beta is just a number.
it's a number. We don't know what it is. And we like to put them in there just to see if you are comfortable with it. It takes a while to get comfortable with it. So it'd be much nicer if that was just 4t,
Yeah.
right? If this were just 4t, you would say 1/4 sine 4t, and it'd be, almost be automatic. With the beta in there, it makes you kind of hesitate. But you get kind of used to it as just being a number that you don't know.
So like beta and pi, they're kind of like the same.
No, beta and pi aren't the same thing. Well,
So if like if beta.
pi is an actual number, like it actually has a value. Beta is a number that I'm not telling you what it is. We'd have to assign a value to it. Pi is actually, everyone agrees what pi is. I'm still not done.
But if you had like 4 pi t,
4 pi t.
like if beta was.
Then this would be 4 pi. This would be 4 pi.
It would still just be 4 pi.
This would be 1/4 pi, yes. But what I was saying is they're not the same in the sense that, hey everyone, what's beta?
You don't know?
We don't, but if I say, hey, what's pi? And everyone will be like, oh, it's like 3.14. Like, we all agree that pi is a certain number. Beta, there's no agreement. Beta is like saying x. Like we don't really know, but we use it a lot for variables. We like to use beta for angles. Alpha, beta, theta, yeah. Still going here. The reason why I'm not done is because there were two terms in here that I could combine together. Yeah, do you see this 1/8 t and this 1/32 beta sine 4 beta t plus c? So just distributing the 1/8 through. This right here and this right here are like terms. So 3/8 t. Agreed? 1/4 plus 1/8 is 3/8. Everything else you could leave alone. These you can't combine together because this one is sine 4 beta t, this one's sine 2 beta t. So, well, I take that back. There probably is some trig identity, some way to get them together, but we're not gonna go for it. This is good enough. But we do want to put the t's together at least. Wow, so that got rather complicated just by raising it up from squared to fourth power, didn't it?
When you grade our tests, like you.
I hate these problems. Yes, I hate these
Yeah, like,
problems.
do you have like a set answer document or anything?
No, I usually make the key every time because I like to time myself and see how long it takes me to take the test.
We were lazy and didn't add the T's together.
That would be one of those, again, those disappointments, you know, where I would be more disappointed in you than anything else.
I'll give you the credit, but
But I couldn't give you full credit. That would be the thing, because if someone did put it all together, then that deserves the full credit, you know?
We just put a.
Yeah. Yeah, I put a little, the tier, didn't we talk about the little tiers? With little tiers. Tiers.
That's like beta, what is that value?
What's that?
That's like beta, what does that value equal?
Beta. All right, so I think that's probably good to get us at least started with the idea of trig integrals. We still have 20 minutes, but I think this is a good point to wrap it up. What we'll do next time is obviously take the test, but then after that, we'll pick up where we left off, and we're going to start looking at combinations of tangent and secant. When tangent and secant are combined together, and that's the right-hand side of this. And then after that, we get into the trig substitutions. All right, that was trig integrals. All right, everyone, I guess that's it, right? There's nothing else? Test Thursday.
So you got office hours tomorrow?
I do have office hours tomorrow, 9 to 1, 9 to 12:30.
Oh, that was 11 to 12.
9 to 12 or 9 to 12:30, yeah, because I usually want to give myself